So let's do a problem of calculation of partial derivatives. Find all the first and second order partial derivatives of the function f of xy equals 2x cubed y squared plus y cubed. Okay, that is our function. So let's start. Let's start by writing down the function f of xy equals 2x cubed y squared plus y cubed. So let's start by doing the partial of f with respect to x. So we assume that y is a constant. Imagine that y it was pi, it was a constant, right? So then what would be the derivative? So it would be 2y squared times the derivative of x cubed, which is 3x squared. So it will be 3 times 2, 6 y squared x squared. Okay, and then plus the partial of y cubed with respect to x. So if y is a constant, the partial derivative with respect to x is 0. So plus 0. Okay, so you can actually remove that. And this is now a function of x and y, which we call f subscript x. Okay? Okay, now partial derivative of f with respect to y. So imagine that 2x cubed is a constant. So we just have to do the derivative of y squared. That will be 2y. So it will be 4x cubed y. And then plus the derivative of y cubed with respect to y. That will be 3y squared. Okay, and this is a function which we call f subscript y, and it's a function of x and y. Okay, now starting from these two functions, which are the two first order partial derivatives, we can calculate the second order partial derivatives. And remember that we have 4 combinations. Okay, so we can first do the second order partial derivative with respect to x, which is the partial with respect to x of fx. Okay, so we need to do the partial with respect to x of this. So this is all a constant, 6y squared, it will be left at the beginning, and then the derivative of x squared, which is 2x, so the answer will be 12y squared times x. Okay, and this is what we would call f sub xx of x and y. Next, the second order partial derivative with respect to y, which is the partial with respect to y of the function fy, which is this function here. So we need to do a partial derivative with respect to y. So this is all a constant multiplied by y, and therefore the derivative is just this constant. So it's 4x cubed. And then plus the derivative of this with respect to y, so that's just 6y. Okay, and this will be fyy, which is a function of x and y. So these are 2 of the second order partial derivatives, but we still have to calculate 2 more, right, when we mix the variables. So let's start by doing the second order partial derivative of f with respect to y with respect to x. Okay, so this means we do the partial with respect to y of f of x. Okay, so we need to do the partial with respect to y of this, so of this here. So what's the partial of this with respect to y? So x squared is a constant, and the derivative of y squared will be 2y, so that will become a 12. So it will be 12x squared times y. Okay, and this will be fyx of x and y. And finally, the second order partial derivative with respect to x and with respect to y, that's the partial derivative with respect to x of fy, which is equal to the partial derivative with respect to x of this function here. So will we get the same result? It's a bit mysterious, right? Because we have 2 terms, we have to do the partial with respect to x. So to do the partial with respect to x, we assume that y is constant. So therefore, the derivative of x cubed will just be 3x squared. 3 times 4 is 12, so we get 12x squared times y, which is a constant, and then plus the partial with respect to x of 3y squared. 3y squared is a constant, so the partial is 0, so plus 0. Okay, so we can remove that. So indeed this will be equal to fxy which is a function of xy. And you can see that these two are equal. As I told you, fxy is equal to fyx. Okay? It's always a bit of a mystery to see how it happens, because you have very different first order partial derivatives here, and then when you do the partial derivative with respect to the other variables, they become equal. Okay? So thanks for watching. See you in the next video.